Hello students, welcome to the next lecture on the linear transformation. Today we will see how we can represent the linear transformation as a matrix form. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the various lectures related to the linear transformation. I hope you can subscribe my channel, as you can see the various topics related to the course content is available at my channel. Now what is the objective is, if you have the linear transformation from V to W, or you can see if you have the transformation from say R2 to R3 or any of the things, then how you can write this transformation in terms of the matrix. That's the objective of this lecture. The last lecture was on how you can verify whether the given transformation like of this or this is a linear transformation or not. Now if you have a mapping then and some basis, then you can target is representation of this matrix as a representation of this transformation as a matrix. Suppose firstly I will tell you the brief theory. Within 1 or 2 minutes I will tell you the brief theory, and then we'll explain you the 12 examples in this lecture. Let's say V and W are my vector space, fine, and capital T is my linear transformation. So since it is a linear transformation, I can assume the dimension of V is my n and dimension of W is my m. What is the meaning of that dimension? That means it has how many basis elements? It has n number of the basis element, and it has a dimension m. So I can say it's a W1, W2 and up to the Wm are my basis elements of this W. Now since if I assume, because my mapping is from V to W, I can choose any element from this, say V of j. If I apply the transformation, because it is linear, it belongs to my capital W. So for each j which belongs to this, for each j I can take the elements, it belongs to W. And since capital T is my linear transformation, what does it mean? That means I can return this as a uniquely representation of a linear combinations of element of W. That means basis of B2. How you can write the linear combinations? So we all know I can return this as a linear combinations of this element, where this Aij are my scalars and it is determined with the help of transformation. And our target is to determine this alpha ij in this lecture. And once you can determine the Aij, then the corresponding matrix which we have formulated is my matrix representation of the linear transformation. Remember that we have considered two different cases. The case one, when this domain and codomain, that is a two vector space, both are my same. For example, like R2 to R2, for example R3 to R3, these are my same. Or you can say polynomial 2 to polynomial dimension 2. So we have the same elements and they have the same basis. Case second, when the domain and codomain of the linear transformations are not same. For example, it is R2 to R3 or R3 to polynomial of 2 or R3 to R4. Fine. In this lecture we will see how we can solve the problems related to the type 1, and the next lecture we will see how you can solve this case 2. That way I will upload it after this lecture. I hope you can subscribe and like my YouTube channel. So let's see how you can solve this with the help of the 12 to 13 examples in this lecture. First of all, because your target is to write the matrix representation, fine. Now in journal, if you want to write this as a matrix T, the first question arises is what should be the dimension of this matrix. The dimension is always be the, what is the dimension of the W cross dimension of the V. Now in this case, what is the dimension of this R2? This is my 2. What is the dimension of the R square? Again 2. So therefore this matrix corresponding to this transformation is my 2 cross 2 matrix. Fine. Now once you know it's a 2 cross 2 or any of the dimensions, look at this, look at the basis of right hand side vectors. What are the basis of this R2? Given by this number. Take any element of R2, take any element of R2 like x comma y. Fine. Now since it has a 2 elements, so we can say because it is a basis, so what is the meaning of the basis? Basis means span and the li. How you can write the li? A span. So because they are the 2 elements, so I can say alpha 1 and alpha 2 are my 2 scalars, such that I can return this x comma y as a linear combination of 5 comma 3 and 1 comma 1. Now your target is to find the value of alpha 1 and alpha 2. You can equate the coefficient of the x component, that is a 5 alpha 1 and alpha 2. Similarly equate the coefficient of the y. Can you solve this? You can easily solve them. You can subtract them. You will get the value of alpha 1, that is x minus y over 2. And how you can find the value of alpha 2? You can substitute the value of alpha 1 either of the equation, you will get the value of alpha 2. Then substitute this value of alpha 1 and alpha 2 in this equation. Fine. Now once you know this is a linear combination, take the transformation. Fine. Find these transformation values at the basis of codomain. Because it's R2, again the bases are given to be this. I can try to find these numbers. So what is the value of this? It is this is the x, this is the y. 20 minus 6, that is 14, and this is x plus y, 8. Similarly, if I substitute 1 comma 1, it is my 2 comma 2. I can write this is my x comma y in this form. What is the x minus y over 2? 6 by 2, 3, 5 comma 3, plus I can multiply here, this is 42 plus 40 divided by 2, that is my minus 1 of 1 comma 1. Similarly, I can substitute 2 comma 2, it is a 0, x minus y, this is the x and this is y, 0, and this is minus 6 plus 10 over 2, that is 4 divided by 2. So therefore, the matrix representation is always written in the column matrix. First value is 3, second value is my minus 1, always written the column vector. Then for the next row, 0, and then plus 2 is the required matrix representation of capital T. Now look at quickly on the second example. So again you can see both have the same vector, so it is my case 1. Fine. I can start from the basis, and because the dimension is my 2, this is my 2, is a 2 cross 2 matrix. Take the bases are given to be my this number. Take any element of the R2 and write as a linear combination of alpha 1 and alpha 2. Equate the coefficients. Again your target is to find the alpha 1 and alpha 2. Find of this. So from here you can see alpha 1 will be your x, alpha 2 will be your x minus y. I can substitute the value of alpha 1 at this point. Now once you know the value of alpha 1 and alpha 2, substitute this value in this case, you will get this transformation. Now given that t of x comma y is x plus y, x minus y, so therefore my target is to find the values at these bases. What is the value of the t 1 comma 1? It is 2 comma 0, and it is my minus 1 comma plus 1. Now I can write this in the form of this. This is the x, this is y. X 1 comma 1 plus x minus y. So x minus y is 2, 0 comma minus 1. You can check your answer in the examination always. You can see if you open this bracket on the right hand side, it is my x comma x plus 0 minus x plus y. And if you add them, you can see this number is my x comma y. Similarly for this case, it's a 2 plus 0 is a 2, 2 minus 2, 0. Fine. Similarly, now for this case, this is my x minus 1 of 1 comma 1, x minus y is a minus of 2, and 0 comma minus 1 is a minus 2. Fine. X minus y. So what is the matrix representation of this? First value, second value, always written the column value, and this is my minus 1 and this is minus 2. So this is the matrix representation of this number. This is a minus 2. Look at the third example. Let capital T is the linear operator on the R3. That means it's a R3 to R3. Then what is the size of this matrix? What is the dimension of this? 3. What is the dimension of this? 3. So it is a 3 cross 3 value. Now take the basis. Basis is given to be by this. Then take any elements of the R3. Now in this case element is my XYZ, which is the element of the R3. Then there exists alpha 1, alpha 2 and alpha 3. There exist alpha 1, alpha 2 and alpha 3 are my scalars, such that I can return this x, y, z as a linear combinations of these numbers. Now you can equate the coefficients. First component is my x, which is equal to, first one is alpha 1 plus alpha 2 plus alpha 3. Similarly for the y is my alpha 1 plus alpha 2, z is my only alpha 1, only alpha 1. Fine. Now your target is to find the value of alpha 1, alpha 2 and alpha 3. From here alpha 1 is z. Can you find the value of alpha 2? This is y minus z. And if I substitute here, alpha 3 will be my x minus 1. So finally you can substitute this value of alpha 1, alpha 2 and alpha 3 in this equation. You will derive this expression. Now you have the linear transformation. Calculate this value at the basis. So firstly, what are my bases? 1 1 1, 1 1 0 and 1 0 0. Substitute this value. It is my 3, x minus, that's 1 minus and 3. Similarly for this, it is my y and z, 2, 1 minus 4 and 3. And similarly you can find the third. Write this number with the help of this expression. Z is my 3 into 1 into 1 plus y minus z. What is the y minus z? Minus of 6, 1 comma 1 comma 0 plus x minus y, that is a 6 times 1 0 0. You can check your answer always in your examination, like 3 minus 6 plus 6, 3. Similarly for the y component, it's a 3, it's a minus 6, it's a 0, it's a minus 3. Similarly you can write this second component, z is my 3, 1 1 1, y minus z minus 6 and x minus y is a 5 times 1 0 0. Similarly you can write this third. So therefore your matrix representation is, write in the column wise, first value 3, second value minus 6, third value plus 6. Then for the second row 3 minus 6 plus 5. Finally for the last column, minus 3, minus 2 and minus 1 is the right answer. Look at this next example. Capital T is the mapping from R3 to R3, fine, which are defined here. So what is the size of this matrix? It should be 3 cross 3. Now since these are my bases, I can start from this any element of x, y, z, which is a part of codomain, and now these have the 3 elements, so I can choose. There are the 3 alpha 1, alpha 2 and alpha 3, so that I can return in this manner. Your target is to find the value of alpha 1, alpha 2, alpha 3. Equate the coefficients, you will get this expression. Now how you can find that? There are the two methods for solving. The first method is, you can solve by subtracting or by adding, fine. And second method is, you can convert this system into the row reduced echelon form, fine. So firstly let me explain you. You can see if I subtract these two numbers, alpha 2 and alpha 2 will be cancelled out. If I subtract 2 and 2 minus 1, you will get this expression. Now you can see you need alpha 1 and alpha 3. If I see from this, if I alpha 1 and alpha 2, if I multiply this number by 2 and subtract from here, then you can see 2 alpha 2 and alpha 2 will be cancelled out. So that means if I multiply second row this minus of the third, then you will get this expression. Now you can solve this. How you can solve them? You can multiply this by 2 and subtract them. So 2y minus 2x, subtract them, plus z, it will be my 2 alpha 3 minus 3 alpha 3. So that means alpha 3 minus of alpha 3 will be minus 2x plus z, or you can see alpha 3 will be my 2x minus z. Fine. Or how you can find the alpha 1? I can multiply this by 3 and then subtract them. You will get the value of alpha 1. Or you can substitute this value of alpha 3 in this equation. You will get the value of alpha 3 and alpha 1. Substitute this value of alpha 3 and alpha 1 in any of these equation. You will get the value of alpha 2. Fine. So therefore your alpha 1, alpha 2 and alpha 3 is the obtained. This is the first method. Fine. In the first method, your target is to write in the two variables. Second method is you can write this system, this met into ax is equal to b form. That is the a 1 2 2 1 2, and then apply the row reduced echelon form. What is the row reduced echelon form? Your target is to write the diagonal as a 1, otherwise rest of the elements as a 0. How you can make the, so that means you can apply r2 minus 2r1, r3 minus 2r1. The first row will be as such. Fine. Otherwise you can use my box element technique. Fine. So this will be my 2 times of this minus 1. It is my 0. It is my y minus 2x. 2 times of this 0. 2 times of this minus 1. Z minus 2x. Fine. Then your target is to make this number as a 1. How you can make this number as a 1? I can divide it r2 by minus 1. So this number will be 1 0 2x minus y, and this element to be 0. So that means I can take r1 to be r1. I can add them, or because now I have to use this value. So this number is already my expression. This. Now finally target is you have to make this number as a 1. So your operation will be r3 divided by minus 1. Then this number will be my this part, and then your target is to make this number as a 0. So this is r1 minus r3, because r3 is my this new number. So your expression will be this one. So therefore this first part is my alpha 1. This is my alpha 1. This is my alpha 2. This is my alpha 3. So either of the method you can opt them, but I always suggest you can opt the first method. Now once you got the value of alpha 1, alpha 2, alpha 3, substitute in this expression. Now final step is you have applied this, calculate this value at the point of the basis, substitute the value of x as a 1, y as a 2, z as a 2. In these cases you will get expression. Write this element in this form. So what is that I can do for the first part? This is a minus 3 plus 1, that is my 1. Similarly 2x minus y, so that means 2 minus 3 minus 1 1 1 2. Similarly for the 2x minus z. Similarly you can compute for this pair 0 2 2, substitute value in these cases, and finally you will get the matrix as first row to always written the column wise. Second is 4 minus 2 minus 2, and the third one is minus 4 2 and 4 are my required expression. Now again you can see this is my case 1, because it's the same dimension. What will be the size of this matrix? Dimension is 2, dimension is 2. It will be my 2 cross 2 matrix. Bases are given to you. Fine. Take any element of this. So say x comma y is the element of the R2. It has the 2 elements. So therefore there exists alpha 1 and alpha 2 such that this x comma y can be written as the linear combination of this. I can equate the coefficients. X will be alpha 1 minus alpha 2. Y will be alpha 1. So can you solve these values? It easily see that alpha 1 is my y and alpha 2 will be y minus x. Fine. So substitute this value of alpha 1 and alpha 2 in this expression. You will get this x comma y. Now find this transformation value at the basis 1 comma 1 and minus 1 comma 0. What is the value of the 1 comma 1? substitute this value in this expression. It is my 2 and 3. When you substitute minus 1, x is my minus 1, y is 0, x is minus 1, y 0. Write this 2 comma 3 in this form. This is y 1 comma 1, y minus x 1 of minus 1 comma 0. Always make sure you have to check your answer in the examination, like 3 minus 1 2, 3 plus 0. Also you can see about here, this is a y and this is minus y plus x. The first part is x. Similarly, you can use this number and you can find these expressions. So what is that matrix representation is? First number is 3. Always written the column matrix. Minus 2 and 2 is my right. I hope you can like and comment on my video. Okay, next one is T is a linear transformation on operator R3. That means R3 to R3. So what is the size of this matrix? So dimension is 3, dimension is 3. So it could be 3 cross 3. Bases are given to you. So it means I can take any element of the R3. I can assume x, y, z is the element of the R3. It has 3 elements. So therefore there exists alpha 1, alpha 2 and alpha 3 such that I can return this x, y as the linear combinations of this basis. Now you can equate the coefficients. X will be alpha 1 plus alpha 2 plus alpha 3. Y will be 2 alpha 1 plus alpha 2 plus alpha 3. Make sure this is the x component, y and y are. Now your target is to find the value of alpha 1, alpha 2, alpha 3. Either you can use the row reduced echelon form, fine, or try to convert this into the 2 system of the equation. That means 2 variable. You can see if I subtract 1 minus 2, what will get? That means x minus y is minus alpha 1. So you will get easily the value of alpha 1. Fine. Alpha 1 will be y minus x. Now your target is to find the alpha 2 and alpha 3. Now you can see if I subtract the second and third, or you can see from the first and third, you can see alpha 1 plus alpha 2 is my z. So alpha 3 will be x minus z. Substitute the value of alpha 1 and alpha 2 in either of the equation, you will get the value of alpha 2. Or you can solve any way of any of the way. Your target is to find the alpha 1, alpha 2, alpha 3. Substitute this value of alpha 1, alpha 2, alpha 3 in this equation, your target is achieved this. Now find this transformation value at the basis 1, 2, 1, 1, 2, 1, 1 and so on. What is the value of this? 2 times z, x minus 2y, so 1 minus 4, x plus 2y, 5. Similarly you can 1, 1, 1, it's my 2 minus 1, 3, and similarly for the last case. I can write this number with the help of this expression y x y z, y minus x, minus 2 minus 3 minus 5, x minus y plus z, so x minus y plus z, so 10 times 1 1 1, and x minus z, that's a minus 3 times 1 1 0. Similarly you can compute for this, similarly you can compute for this third case. Now write this matrix into the column form, that's a minus 5, then 10 and then minus 3. Similarly for the second row and the third. Look at the next example. Again it's a linear operator on the R3 to R3. I can write this. Bases are given to you. So the matrix is of dimension 3 cross 3. Take any elements of this right hand side, that is a codomain vector space. Now it has 3 vectors. So there exist alpha 1, alpha 2 and alpha 3 such that I can return this x, y in form of. Again your target is to find the value of alpha 1, alpha 2, alpha 3. You can equate the coefficients, you will get this expression. Now again you have the 2 different methods. You can use the row reduced echelon form or try to simplify this expression. How you can do that? You can see first and third, if I add them, alpha 2 will be cancelled out. So if I add first and third, your target is the x plus z is 2 alpha 1 plus 3 alpha 3, or you can subtract them as well, then it will be in the form of alpha 2 alpha 3. It's on your choice. Fine. In this case I have subtracted them. Fine. You can add them or you can subtract, it's on your choice. Now you can see this is expression of alpha 2 alpha 3. Now I have to solve these equations or this equation in terms of alpha 2 alpha 3, but you can see one equation is already in terms of alpha 2 alpha 3. Fine. Now you have the two equations. I call this is equation number 4. Fine. Now you can solve equation number 4 and equation number 2. How you can solve them? If you add them, what is the value of this? So if you add them, you will get, this is my alpha 2, fine, it's a 4, and if you subtract them, you will get the value of alpha 3. Substitute the value of alpha 2 and alpha 3 in either of the third or in the first, you will get the value of alpha. Now you can simplify this. It will be 4 is the LCM and you will get this. Now substitute this value of alpha 1, alpha 2 and alpha 3. In this case, you will get, this is the required expression. Now on this basis B, find these capital T values. I can substitute this value of T 1 0 1. So it is my 3 plus 1 4, minus 2 plus 0, minus 1 0 4, that is 3. Similarly, you can compute for the second part and for the third part. Write this element with the help of this case. So first case is minus 4 plus 6 plus 15 divided by 4 of 1 0 1. Y plus Z minus 2 plus 3 minus 4 divided by 4 of minus 1, and so on. Now you can see what is the value of this. It's a 2, it's a 17 over 4 1 0 1. This number will be 1 minus 3 over 4 minus 1 2 1. Similarly, you can compute the rest elements. Similarly, for this case, substitute this value in these pairs, you will get this matrix, this pairs. So what is the final answer of this? You can write the first number, then second column, first column, and then similarly for this pair 35 by 4 17 in the second column, third column is the required answer. Okay, look at this another one. You can see it's the same. So what is the size of this matrix? It is my 2 cross 2. Take any element of the R2, that is my x comma y is the element of the R2. You have the two bases. Therefore there exists alpha 1 and alpha 2 such that you can return this number in this manner. Equate the coefficients of the pairs. Now how you can solve them? Can you solve them? It's very easy. You can see if I multiply this number by 3 and subtract them, so you will get as 3x minus y, it will be 0, 9 minus 4, 5 alpha 2. That means alpha 2 will be 3x minus y over 5. Then second part is how you can find the alpha 1. So how you can find the alpha 1? I can multiply this number by 4, this number by 3 and then subtract it. So it is my 4x minus 3y, it is my 4 minus 9 minus 5 alpha 1. So alpha 1 will be 3y minus 4x over 5. So you get alpha 1 and alpha 2 in a simple manner. Substitute the value of alpha 1 and alpha 2 in this equation. Now based on this transformation, find the values at 1, 3 and 3, 4. What is the 1, 3 is 3 minus 12, so that's a minus of 9. 1 plus 15, that is a 16. And similarly for the second. Substitute this value of the x and this value of y in this expression. So you will get 3 into y, 14, 48, minus 4 into x, 4 into 36 over 5. So that will be 74 over 5 into 1, 3 plus 3x minus y, minus 27 minus 16 divided by 5, that's a minus 41 over 5 of 3 comma 4. Similarly, you can compute for the second pair. It is a 43. It is 84. Fine. So that is the calculation. Now similarly, you can use this x and this y, substitute this value at this point, you will get this x. In the examination, you can always check your answers quickly. You can use the x component, you will get a -7. You can see this as a y and this as a y, you will get 60. So what is the final matrix representation? So my final matrix is 84 by 5 minus 43 by 5, 97 and minus 44 by 5. Okay, look at this another one. Again, it's a R2 to R2. So the matrix size will be my 2 cross 2. Take any elements of the R2, write as a linear combinations of this. Equate the coefficients of this. How you can solve them? I can multiply this by 2 and add them. You will get 2x plus y is my minus 2 alpha 2 is a minus 6 plus 4. So alpha 2 will be minus 2x minus y over 2. Substitute the value of alpha 2 in either of the equations, or how you can find the alpha 1? I can multiply by 4, multiply by 3 and add them. So that means it's a 4x plus 3y minus 4 plus 6, that is my 2 alpha 1. Alpha 1 will be 4x plus 3y over 2. Otherwise you can substitute the value of alpha 2 in either of the equations. Fine. It's a minus 4, it's a minus 4, it's a plus 6, it's a plus of 2. So alpha 1 will be the positive sign. Now substitute this value in this equation. Now you can see I have written is a negative sign. Okay, you can see whether the answer is, my answer is correct or wrong. If I open this bracket, it is 4x plus 3y over 5 for the component, and for this case it is my plus 6x plus 3y over 2. Clearly say this number is my not x. So that means this answer is my wrong. So that's why, because I have computed alpha 1 is both as a positive number. So this is my positive, this is my positive. Now you can see whether this is correct or wrong. Now you can see it's my 2. Fine. So 2 will be the LCM, 3y will be cancelled out, 6, and you can see now it is a x. Fine. Now write this capital T in the form of this, it's my plus and this is my 2. Substitute this value here. Fine. Now you can calculate this value. So when x is 1, y is 3, so it is 4 plus 9, that is my 13 divided by 2, plus x is 1, y is, so minus 3 minus 2, that is a minus 5 divided by 2 of minus 3 comma 4. Again you can check your answer whether it's the same or not. So it is a plus 13 by 2. Fine. Similarly, if I substitute minus 3 and 5, you will get this number. This is a positive, this is my, I can check what is the answer is, it's a positive. So it is my minus 12 plus 15, that's a plus 3. So the answer is plus 13 by 2, minus 5 by 2, plus 3 by 2 and plus 1 by 2 is the right answer of this problem. I hope you can like, comment and subscribe my YouTube channel. Look at one more example. So this is the R2 again. Fine. You can see this is a 1 comma 0 and 0 comma 1. This is called as standard basis. Whenever this is called as a, sometime it is called as E1, but it is a 1 comma 0. E2 is 0 comma 1. Anyhow, I can take the element of the R2, write this pair. So what is the value of the x? Alpha 1 plus 0, 0 plus alpha 2. Now you can see it is already computed the value of alpha 1 and alpha 2. So substitute this value of alpha 1 and alpha 2 this. Find the pair of 1 comma 0, find the value of this. What is the t of 1 comma 0? This number is my 5 comma 1 and this number is my 3 comma 2. Write this 5 comma 1 with the help of this expression, x plus y, y is my 1. You can see that if you open this bracket, it will be here. It is my 3 1 comma 0 and twice of 0 comma 1. So what is the matrix representation? So the matrix representation is, first column is 5, and then 1, and then 3, and 2 is the right answer of this problem. So this is the way you can solve this type 1 related problems. We will see the next part, that is when vector spaces are not same, how you can write the matrix and with the help of the various examples. Till then, you can share this video with your friends. Best of luck, students. Happy learning.